The next sum is purely a rectangle property sum. I want to say the next sum which you are going to see is a sum totally on rectangular property of circle. What's a rectangle property of circle? Whenever two chords, how many chords? Two chords intersect each other in the interior of the circle, the product of the lengths are what? Equal. See in this sum what is given to you. AX is what? 4 centimeter. XB is what? 2 centimeter. XD is 5 centimeter. And OX is 1 centimeter. By using all this information, what do you have to find now? You have to find or you have to calculate CX. Can you see CX? Where is CX? Yes, it's very much clear. And the second thing what is there, you have to find the radius of the same circle. You have to find the radius of the same circle. First, we'll try to find CX. Now see this very carefully. Chord AB and CD intersect in the interior of the circle. Where they intersect? In the interior of the circle. Therefore, by using rectangle property of circle, what I get? I get XA into XB is equal to XC into XD. That is nothing but 4 into 2 is equal to XC into what? 5. That is 8 is equal to 5 XC. That is 8 upon 5 is equal to XC. By calculation, by simplification, what I get? CX is equal to what? 1.6 centimeter. So my first part is over. CX is equal to 1.6 centimeter. Now I have to find the radius. See, radius, when two chords intersect in the interior of the circle, how do you find the radius? We can get the radius with the help of XA into XB is equal to R square minus OX square. By putting down the values, what do you get? 4 into 2 is equal to R square minus 1 square. That is 8 is equal to R square minus 1. 9 is equal to what? R square. Root of 9 is equal to what? R. Plus or minus 3 is equal to what? R. But geometric parts can't be negative. Therefore, R is equal to 3. That is, radius is equal to what? 3 centimeter. And the sum gets over. Now see the next sum. It's a purely proving sum. My favorite sum. It's a very interesting sum. See what is given to you. See the figure very carefully. A straight line ACBD. Can you see that straight line? ACBD. Yes. What else? Cuts two intersecting circles at A, B and CD. And cuts the common chord of the two circles at point X. It's a very interesting sum. What do you have to prove now? You have to prove that XA into XB is equal to XC into XD. Now the figure looks a bit complicated. But what I'll do, I'll make it more interesting for you. I'll separate these two circles. Yes, I get circle 1 and I get circle 2. Okay. Can you see this? Yes. In circle 1, what I get? Chord AB and EF intersecting at point X. Similar in circle 2, what I get? Chord CD and EF intersecting at point X. Whenever two chords intersect each other, we can use rectangular property of circle. That's what I'm going to try now. In circle 1, XA into XB is equal to XE into XF. What's the reason? Whenever two chords intersect in the circle, in the interior of the circle, products of the lengths are what? Equal. That means I'm using rectangular property of circle. Similarly, in circle 2, what I get? I get XC into XD is equal to XE into XF by using the same property. That is rectangular property of circle. When you see the first and the second statement now, by transitive property, what I get? I get XA into XB is equal to XC into XD. And the sum gets over. I made it very easy for you. Yes or no? Yes. So when you see a next sum, it's a very good sum. It's a combination of similarity plus I have put a quadratic equation in the circle chapter. Yes, you will understand when you start solving the sum. Come on, let's see the figure first. What is given to you? AB is equal to 7.5 centimeter. What is AB? 7.5 centimeter. BX is 1.5 centimeter. So you should know where is BX. Can you see that? BX is 1.5 centimeter. And CD is 6.5. Okay. With all this information, what's the first thing you want to find? You want to find CX. Now, where is CX? Yes, you can see it very clearly. One more thing you can see from this figure, there are two chords called AB and CD intersecting at point X. So by using rectangle property, I can find CX. Yes or no? I should know XA into XB is equal to XA into what XD. But all the things are not very clearly given to you. For example, we have got AB. XA and XB is not given to you separately. In short, XA is not given to you separately. So what you'll do? First you'll find XA. How to find XA? XA is equal to AB minus what? XB. That is 7.5 minus 1.5 centimeter, which gives me 6 centimeter. So what is 6 centimeter? XA. Yes. What else? CD is given to you 6.5 centimeter. CD is given to you 6.5 centimeter. And I want to find what? CX. If it's not given, let's go for a X method. Let CX be equal to X. If CX is equal to X, what will be XD? X is nothing but 6.5 minus X. Okay. Now by using the rectangle property of circle, what I get? I get XA into XB is equal to XA into XD. Now by putting the values into the formula, what I get? Just check it now. Just see it now what is given. I get 6 into 1.5 is equal to X into 6.5 minus X. After further simplification, what I get? 9 is equal to 6.5x minus what? X square. Further simplification gives me x square minus 6.5x plus 9 is equal to what? 0. After factorization, see I told you you'll get a quadratic equation. You got it. So after factorization, what I get? I get x minus 2 or I get x minus 4.5 is equal to what? 0. So what I get? X minus 2 in one bracket and I get x minus 4.5 in another bracket equal to what? 0. That is x is equal to 2 or x is equal to what? 4.5. In short, both the answers are coming positive. So what I get? Either CX is 4.5 centimeter or CX is what? 2 centimeter. So we have to take one of them. Okay, let CX be equal to what? 4.5 centimeter. Therefore, XD will be CD minus XC. That is 6.5 minus 4.5. That is nothing but what? 2 centimeter. So what is 2 centimeter? XD. So that is over. So you have already found CX. CX is what? 4.5. If I take CX is what? 4.5. XD will be what? 2 centimeter. Correct? We take the second part of the same sum. What do you want to prove? You want to find triangle ACX upon triangle BDX. That means I have to use similarity over here. First of all, I want to prove these two triangles are what? Similar. Yes, this is both the triangles similar. By which test? By AA test of similarity, I can prove that triangle ACX is similar to what? Triangle BDX. When two triangles are similar, the areas are in proportion to what? Side square. I repeat once again, the areas of similar triangles are in proportion to what? Side square. So what I get? Area of triangle ACX upon area of triangle BDX is equal to AX square upon DX